Ternary computing, the next big thing for AI executive summary. Ternary computing uses three states, -1, 0, and +1, to process data more efficiently than binary. Technologies like Microsoft's BitNet 1.58b apply this logic to AI software. Meanwhile, Huawei is developing specialized ternary chips to reduce feature size, power use, and transistor counts. A 7-nanometer ternary chip will perform as well as a 2-nanometer binary chip. This combination allows massive AI models to run on standard consumer hardware. It reduces the need for expensive data centers. Consequently, ternary computing makes powerful AI accessible on millions of existing personal devices. Article. Most computers today use binary logic. This system relies on two states, off and on. We represent these states with the numbers 0 and 1. This system has worked for decades. However, artificial intelligence, AI, requires massive amounts of power. Modern AI models process billions of numbers at once. These calculations create heat and consume huge amounts of electricity. A new approach called ternary computing might solve these problems. It introduces a third state to the digital world. This small change could transform how we use and share AI. The basic concept: moving beyond bits. Ternary computing uses three states instead of two. In binary, we use a bit. In ternary, we use a trit. A trit can represent -1, 0, or +1. This is often called balanced ternary. This system is very efficient for math. Binary systems struggle with negative numbers. They must use extra bits to show a minus sign. Ternary systems handle negative values naturally. One trit carries more information than one bit. A ternary system has higher information density. It can store more data in the same amount of space. This reduces the number of parts needed for a computer. It also makes mathematical logic simpler. Computers perform addition and subtraction much faster with three states. Scientists first built ternary computers in the 1950s. However, binary technology became the industry standard first. Now the high costs of AI are bringing ternary back. BitNet, the software revolution. Software must change to support new hardware ideas. Microsoft researchers recently developed a model called BitNet 1.58b. Most AI models use complex floating point numbers. These numbers are precise but very heavy. They require 16 or 32 bits of memory each. BitNet changes this by using ternary weights. Every parameter in the model is either -1, 0, or 1. This software acts like a bridge. It allows AI to think in three states. BitNet performs almost as well as traditional models. However, it is much more efficient. It replaces hard multiplication with simple addition. This change saves a lot of energy. It also reduces the memory needed to run the AI. You can fit a large model into a much smaller space. This makes it possible to run powerful AI on a single chip. Ternary chips, Huawei's hardware breakthrough. Engineers are now building physical chips for this logic. Huawei recently patented a new ternary logic gate. This circuit can add and subtract using 3 voltage levels. Traditional chips use low and high voltage. The Huawei design adds a medium voltage level. This allows the chip to distinguish between -1, 0, and 1. These chips offer 3 main benefits: fewer transistors. Ternary chips need about 40% fewer devices than binary chips. Lower power. They use up to 60% less electricity. Higher speed. Calculations happen 20% faster because the logic is simpler. Huawei is using these chips to bypass physical limits. Modern binary chips are getting too small to build easily. Ternary logic allows more power without making the parts smaller. This hardware is a perfect match for models like BitNet. Together, They create a very fast and cool running system, improving the distribution of AI. This combination could change who can use AI. Currently, AI lives in giant data centers. These centers cost billions of dollars to run. They require specialized GPUs that are hard to get. Ternary computing moves AI out of the clouds. Because ternary models are small, they don't need giant servers. Ternary hardware and software make AI portable. We can put smart features into small devices. This helps people in areas with slow internet. It also protects privacy. If the AI runs on your device, your data stays with you. This technology makes AI a tool for everyone, not just big companies, running on existing devices. You might think we need to throw away our old PCS. That is not entirely true. BitNet models can run on millions of existing devices today. Modern binary processors can mimic ternary logic. They use simple software tricks to handle the -1, 0, and 1 values. Even without special ternary chips, these models are very fast. Old laptops and smartphones have enough memory for ternary AI. A model that usually needs 16 gigabytes of RAM might only need 2 gigabytes in ternary form. This breathes new life into older hardware. It turns a regular PC into an AI workstation. Eventually, new ternary chips will arrive in stores. These will make our devices even more powerful. We are entering an era where your phone could be as smart as a supercomputer. Here is a comparison of how ternary computing stacks up against traditional binary systems in the context of AI and hardware efficiency. Metric, binary, FP16/standard. Ternary, bitnet/trite. Improvement/benefit. Information density. 2 to the power of n states for n bits. 3 to the power of n states for n trits. Approximately 58% more data per unit. Energy consumption. High, heavy multiplication. Low, simple addition. Up to 71 times less energy, bitnet. Logic gate complexity, 4 cases per gate, 9 cases per gate. Higher throughput per cycle. Transistor count, 100% baseline. Approximately 60% Huawei patent. 40% fewer physical parts. Processing speed, 1.0 times baseline. 1.2 times faster. 20% speed increase in chips. Memory footprint, 16 bits per parameter, 1.58 bits per parameter. Approximately 10 times memory reduction. Key takeaways for AI software efficiency. Models like BitNet 1.58b prove that ternary AI can match the accuracy of heavy models. This makes it possible to run large language models on devices with limited RAM. Hardware leap. Huawei's patented ternary logic gates use multiple voltage thresholds. This allows a single circuit to do more work. These chips generate less heat and fit more power into a smaller space. Massive reach. Because ternary models require less power, they don't need expensive cooling or power grids. This allows developers to distribute advanced AI to millions of existing smartphones and PCs.